In PSpice, you can perform sensitivity and worst-case analysis to find the worst probable output of your circuit for set component tolerance ranges. For this, first the component tolerances need to be set, which can be done easily using a sign tolerance dialog. In the global list of components, set the tolerance for all the resistors and capacitors present in the circuit. Next, edit the circuit simulation profile set for AC analysis and enable the worst case option. Set the output variable for which the measurement will be set to calculate the worst case. In the worst case sensitivity section, you can set what type of component tolerances must be varied. You can also define a device type to limit the variation and save data for each sensitivity run. In the More Settings dialog, set the collating function which defines the measurement of output variable. You can define the sweep range and set worst case direction, which sets the direction of collating function with respect to the nominal value. Close the simulation settings, save the design, and run the simulation. The simulation will have data for nominal and worst case runs separately. Select both of them to see the output waveform. The green waveform represents the nominal run, and the red waveform represents the worst case run. Open the simulation output file and scroll down to find the text which states the range defined for measurement. Below this, the component which is most sensitive to measurement is listed first by following components in decreasing order of sensitivity. It also lists the percentage change in a measured result for 1% change in component value. Scroll down to find Worst Case All Devices section, which lists all the components with new values that led to worst case result. Finally, in the Worst Case Summary section, it lists the worst calculated value of output variable at positions in the x-axis, which for this case is 194.1 kHz. This value is measured to be 148.25% higher than the nominal calculated value. This is how you perform sensitivity worst case analysis in PSpice to identify the impact on key circuit measurements.